Calculus 2. Today we are reviewing integration. We're going to talk about basic integrals. We're going to take a look at some of the algebraic manipulations that need to be done. We're going to take a look at the U substitution, at the backwards U substitution, or back substitution as it's called shorter. So we're going to talk a lot about all of these different problems. Now, let's immediately start with noting that the page 511 has the table of basic integrals. And you learned all of these in your Calculus 1 class, so you should know all of these formulas. Now, we are going to just take a look at the integral of sine x dx is equal to negative cosine x plus c. Please make sure that you have this plus c every time when you are doing an indefinite integral, meaning no limits. If you have integral from, let's say, 0 to 1 for e to the 5x dx, you would integrate, which means e to the 5x over 5, and then you would compute that between 0 and 1. So this is another basic idea. We know this as a fundamental theorem of calculus, computing the integral at the limits. So it's going to be e to the 5 times 1 divided by 5 minus e to the 5 times 0 over 5. There is no plus c this time, obviously. And we're dealing with e to the 5 over 5 minus 1/5. No plus c. So we are differentiating now between the definite and indefinite integrals, whether we have plus c or not. So now that you know all of the basic integrals and you know how to compute each one of them, we can take a look at spicier examples. So we start by U substitution. We're going to do a number of examples. Let's first start with the integral of dx divided by, how about 10 minus 8x? We can do this. So when you're solving integrals, especially when you move later on in chapter 7, there should always be these questions when you see a problem. First question is always, is this a basic integral? And the answer is no, right? Immediately. If it was dx over x, then it's a basic integral. But because it's dx over 10 minus 8x, it's not basic. And then the next question is immediately, can I use u sub? Well, if I put 10 minus 8x to be u and have du to be minus 8 dx, when I take the derivative, make it into differential, I see that I can transform my integral. The denominator is going to be u. And then you see that you only have a dx, so one of the possible ways to do this would be to say dx is equal to du over negative 8. And then plug that there, which would give us negative 1 over 8 in front of the integral, and then have du over u. So I would say it's crucial for you guys to see that we took the integral, which was not basic in any way, and transformed it into a basic integral. What is this integral? ln u. Awesome. So we took a non-basic integral and using u sub transformed it into a basic integral, which is ln u in this case. So don't forget the absolute values. Hold on, there's a plus c right there. Don't forget the absolute values of ln. and don't forget the plus c. Now we want to go back to the original variable, right? So we say one of those, I don't care about you, I care about the x. Whatever. Finally, you're welcome. Yes. And the problem is solved as soon as x is back in the picture.
What if it was x over 10 minus 8x?
What was, can you tell again?
X over 10 minus 8x?
Like this.
Yeah. Would the x be the dx?
Let's see. I don't know. Let's see what happens. So now we have a modification on a previous problem, and the only difference is now we have this x in the numerator. Earlier we had 1, right? 1 times dx. Now we have x times dx. So I'm going to try and do the same thing, because we are still in chapter 5 and 6 and we don't know anything else, right? So u equals 10 minus 8x, and du is equal to negative 8 dx. So now as I do substitution, I have u in denominator, and then I have du over negative 8, right? That's the dx. But what do I do for that x? It can't. The entire integral has to shift from the x domain into u domain. And there is a way to fix this. Yes, anyone, please. Solve substitution u for x. Very good. That method is called back substitution. So we solve this one, right? We solve this one, move 8x to the left, and move u to the right, and then divide by 8 everywhere. And that's what goes on top. Now we have this over 8 and then the negative 8, so that can be negative 1 over 64 in front of the integral. And what I have is 10 minus u over u du. Is this better in any way? So is this better? And if it is, why is it better? What should I do next? What now? Very good. Separate into two fractions. So I have to use parentheses now. So it's 10 over u minus u over u is 1 du. And now we're talking about two basic integrals. The first one is ln, and the second one is u, me. All right. So we have 10 ln absolute u minus u plus c, and we bring back the x again. Every time.
You have to bring it back because there's so many limits that we can change.
Yeah. Because one of these indefinite integrals. Let me just see, make sure that the stream is live. Yes, it is. Okay, good. Are you happy?
Yeah.
And you just stumbled upon the other one that we need to talk about today, which is the backwards U sub.
That was the backwards U sub?
That was the backwards U sub.
What part was the backwards U sub?
The part where we did this to deal with this. Now I'm not going to solve it, but one of the standard questions for backwards U sub would be integral of x times square root of x minus 1 dx or something of that nature, where you can use U sub in a similar backwards U sub. So this is another example. Another example of the problem above. Let's take a look at, how about this problem? Nice. It is 2 times sine hyperbolic plus c. Awesome. Now, yes, you can go on and do the integrals of these and get e to the x minus e to the minus x plus c. That's correct. It's 100% there. But you could also be cool. You know from 6.10 that this thing over here divided by 2 is cosine hyperbolic, right? It's missing over 2, so here. Right? So now it becomes 2 integral of cosine hyperbolic x dx, which is 2 sine hyperbolic x plus c. Just to be fancy, all right? Absolutely no other reason. Yes. Which one? The one on top or one on bottom? Yes. Plus, guys, you need to know these hyperbolic functions for differential equations. Last night, after I was walking out on my office hours, I saw 2 students cranking differential equations in the math department on the board in the middle. Solutions to some of the second orders are hyperbolics. You gotta know this stuff for your next class. It's not just let's pass Calc2. It's a lot about pass Calc2. No, Calc3 is Calc3. Differential equations is in some school called Calc4. But it is, yeah. If you're going to differential equations, make sure 6.10 has to be clear, because half of your solutions will be there. What's the integral of tangent x? All right, do this one. Because you can. No coffee. What's the method that we are using? U sub. What else, right? What's U?
Cosine x.
And what's du?
Negative sine x. Yes.
No negative points. All right. We fix that negative sign up there, so we have minus integral of du over u, which is? Yes, plus.
C.
Which is equal to?
Negative ln cosine x plus C.
Should we leave it like this? And the answer is hell no. What are the trigonometric pairs for calculus? Sine and cosine? Tangent and secant. Because derivative of tangent is secant squared, derivative of secant is secant tangent. Integral of secant squared is tangent, integral of secant tangent is secant. The pairing is done tangent with secant. Look at the integral of tangent. Should not be a cosine there, right? And luckily, it's not. That negative 1 goes in as the exponent, right? Which means reciprocal, 1 over cosine is secant. We cannot escape this pairing in calculus. It cannot be escaped. If you see a problem that has, let's say, a tangent paired with a sine, that means immediately that you have to use trig identities to bring that tangent down to sines and cosines and use exclusively sines and cosines to solve it.
Can you say that again?
If you see a problem that pairs sine and tangent, let's say, which are not proper pairs for calculus, you immediately know that you have to transform that tangent into sines and cosines. We'll see examples like that.
Can I really ask you, to clarify, I follow up with what you're doing here. This is accounting for this. This is accounting for this in that you're putting a negative here, and then of course you have to put a negative over the balance.
Yes. Minus and minus gives plus. Yes, perfect. So are we all clear what happened there? And are we all clear with the rules of exponents for logarithms? I will write that formula here just in case.
So why?
Ln of x to the p is the same as p ln x. If you don't remember that formula from your pre-calculus class, that's exactly what happened. This -1 went as the exponent, -1, cosine -1. So that's not -1, that was inverse. It's just a reciprocal.
So the -1 just becomes 1? Like why couldn't it be -1 cosine x? Like -1 over cosine x?
Absolute value.
Oh, absolute value.
No, 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 no. The -1 goes from here, there. Well, actually, better if I write it this way. And we know that x to the -1 is the same as 1 over x.
Yeah, okay, gotcha.
Awesome.
My bizzle.
Let's see what the book has as example 3. Nothing major. It just says cosine x and then plus sine cubed x. Everything divided by a secant x and then dx.
Okay, so
That's example 3 in textbook. They think that's fun? 7.1.
One example.
Example 3, yes, in the textbook. This is worked out in the textbook, so please don't cheat. Close the books. Yes?
We never finished that problem where you spent like 15 minutes staring at the board. I don't know if we passed that problem next year.
Which one?
The problem where you stared at the board for like 15 minutes. Like,
I'll have to take a look at it. I'll probably stare at it when we do the lab. I'll figure it out
I
now.
have it right here.
Awesome, thank you. Keep it. Yeah, don't lose it. Guys, again, for the 15th time today, what are the calculus trig pairings? Sine and cosine. Secant, tangent. Okay, so you know the pairs. Well, some of you at least know pairs. Now, what's the oddball here? Secant is the oddball. Can we fix it?
yes.
How? And then what? And then algebra, exactly. Okay, so write secant as 1 over cosine. Unleash algebra upon the expression. And see what happens.
It's just cosine x. So if we rewrite it, this denominator is part of the this Actually, yeah, you're right. You can rewrite as cosine squared x sine cube x cosine. Yeah, yeah. But for some reason, why don't I feel like if you take out a sign here, I feel like this becomes 1. And it becomes cosine squared x plus sine x. No, I know it's something. No, there's like an identity where it's like cosine squared x plus sine squared x is equal to 1. So if you take out a sine x from the cube, I do. You see what I'm saying? I think it becomes 1 and then it just gets fucked over into the shape of 1. And that's what I'm saying. I don't know. The derivatives for my class.
One of them would become the other. Yeah, I already had that.
I see what you're saying.
So I hope we all have the same algebra, right?
Yeah.
Awesome.
Yeah.
Now what?
Just break it up into two integrals.
I break it up into two separate integrals. That's awesome. So we have integral of cosine squared x dx plus the integral of sine cubed x cosine x dx. Now what?
Cosine squared.
I didn't get the same out.
Why?
Well, I don't know.
We're dealing with a double fraction.
Bring the denominator to the top so it becomes
I know what I did. Yeah, I know what I did.
Okay.
Cosine squared of x, you can change that to 1 plus cosine 2x over 2.
How's that called?
Power reduction.
Power reducing for power reduction. You're going from the second power down to the first power. It's a power reduction formula. It is the only way to do this integral. If you don't know power reducing formulas, and I told you that on the first day, it's just done on that problem, I mean. There is no other way.
Why, I have a question. Why is it that you can't use the power, like the power rule for integrals to change that? Why can't you do that?
Nope. Because it doesn't work. When you get the answer and you take the derivative of it, you see that it doesn't work. We're going to use the power rule here.
Yeah, I know that.
Yeah. They don't look remotely the same because this one has function derivative pair, the other one has a function but no derivative to it. You don't have enough building blocks for u sub. There is nothing you can do other than. Yeah.
I remember the first time I
Every day. It's Calc2. Every day.
Oh, so wait, is that becomes 1 plus cosine of 2x? Yeah, over 2. Right? That's a rule.
Yes.
Next to the last line. I understand you pulled the 1/2 out. Oh, what x equals is the 1. Is that correct? Yeah, okay.
So I hope we all have the same. Okay, then make it the same.
I made mine better. I have x over 2, sine 2x over 4. I don't have all the
Okay.
Will we be given extra scrap paper for the test?
Every other page will be blank, so you can, because I print the exams only on one side, so the other side of that page is blank. So if the test is, let's say, 17 pages, you will have 17 pages of test and 17 pages of empty paper. Ain't gonna be 17 pages. That was just an example. It was the first number that crossed my mind. What? Yeah, the test will have 666 pages. Yes.
Oh.
Wait, so if we ask for the test on a Monday, the test therefore be shorter because we have to.
Yes, that's correct.
Then again, I hate plus twice.
You guys are gonna love this next problem. Integral of x squared plus 2 divided by x minus 1 dx.
Professor,
Yes. I'm
would
busy.
that be wrong to make u x squared plus 2?
Yes.
I would be wrong?
Yes.
Okay.
One fraction. Is that partial to because it's in the denominator? How is this something equal to the denominator? I'm not sure why.
Because your derivative cannot end up being in denominator usually. That's why.
Yeah,
But let's start with the first question. Is this a basic integral? No. Do we have a function derivative pair? Unfortunately, no. Because the derivative of x squared is 2x. You need an x squared minus 2x there to have this situation, right? But then even if that was true, they will be swapped. You can't force the du part to be in the denominator. So it's completely backwards for u sub. So it's not u sub either. But that's the only technique we know. And it's not back u sub. If it's not u sub, you have to start backwards u sub with u sub. Yes?
But can you factor the x squared plus 2?
It factors over complex numbers. That will be x minus 2 root 2i times x plus root 2i. So we can't factor it.
I'm gonna answer the question. The answer was, you can't put the du in the
Denominator, exactly. Because it's always times dx, times du, never divided by. So we can't do any of that stuff. Yes? But we don't know. Yeah, we haven't covered. It wouldn't work, but we did not cover what you're suggesting, which is the by part.
You said you can't use x minus 1.
Would it make a difference if you multiply the top and bottom by a certain number?
Unfortunately, no.
X squared the whole way?
No, because you don't have, if you square it, right, you are only allowed to do that in equations.
Oh, that's right.
You bring x minus 1 up top.
Nope.
You just divide.
You divide.
Divide like.
Yeah! Who remembers the long division of polynomials?
Oh my god.
Ah.
No.
Welcome, long division of polynomials. How are you doing? Sit down, relax, and divide. All right, so we're going to now, since you are dividing by a linear term, you are actually allowed to use synthetic division if you remember that. But if you have anything else other than, right?
Can you say that again?
Since you have a linear term over here,
Okay.
you can use synthetic division. But maybe you just want to do the long division because it's universal and it works in every case.
I forgot how to do it.
What will be something I remember later?
Seeing if I can remember the muscle remember.
The two tutors in class are like, yeah.
That was
And the rest are like, oh, long division of
small
polynomials.
face and
No. Didn't we learn that one for the exam 2 years ago and then forgot it?
I do not remember how to do it, to be honest.
Calculator.
Calculator, oh my god. So the algorithm for long division of polynomials is identical to algorithm for dividing numbers, except now you divide x. So x squared divided by x is x, and then you multiply back and subtract.
Am I correct in remembering that?
And you have to put the placeholder after x squared. So it has to be x squared plus 0x plus 2 divided by x minus 1.
Once you have every degree, you count down, so you have 2, 1, 0, and you have x go into x squared, x, and then you multiply x times x squared, or negative 1 is negative x. And then that's negative x plus.
Which math and numbers?
X squared minus x. Multiply x minus 1 times x.
No, the line to winter is coming.
You don't have the notes. The only ones you have left in Calc1 class, which composition, okay? You'll find like the notes on.
Long division of polynomials is in chapter 2.
The only notes you have listed here are 171.
Oh, I probably listed it only as a concept.
Remainder would be plus 1 over the exponents.
Ooh, boss, you're clashing?
Yeah, I stopped for a long time.
Hey,
I
sir,
got tired of saving so much. It's like everything's so expensive to upgrade.
Oh, I killed your base. I
did?
remember.
You rated me?
All right, let's talk about long division a little bit on the side. X minus 1 divided into x squared plus 0x plus 2. We use the placeholder over here. X goes into x squared x times x is x squared minus x. And then we subtract. These guys die. So we have x plus 2 over here. Because 0x minus and minus gives me plus. So 0x plus 1x is 1x. And then we drop down plus 2. X goes into x plus 1. Multiply it through. We get x minus 1. Again, subtract. These guys die. 2 plus 1 is 3. So plus the remainder of 3 over x minus 1. So our integral now becomes open parenthesis x plus 1 plus 3 over x minus 1 everything dx. So we know it's x squared over 2 plus x plus 3 ln absolute x minus 1 when you do u sub plus c.
What are you doing? Oh, I did one. I got it.
So I skipped the u substitution part that brings that into ln, which you can fill in, because we did it already twice. But then I was made aware by our master tutor over here that this can be done in the other way. So please present, because I'm apparently a noob. I don't know what are your favorite colors. I got all of them. So he's going to use u sub.
But it doesn't look the same like this.
Oh yeah. Oh yeah. Why is that X? Not true.
Except like when this distributes to 2, like that's another time.
Oh, I see.
Awesome. So apparently it can be done. I thought it can't. I didn't look closely at all. That's why we have tutors, right? And this is actually how good our tutors are. So he's working at a tutoring center. Matt's working at a tutoring center. Go, guys, go there if you need help. You will find it. Now, what happened?
That's not first though.
You're not selling it. You're not selling it. And where's the thank you? Yeah. Mina.
First one.
Oh, I didn't know that they first will play the first name.
Yes.
It's not like it's harder than I left. I was the first one to learn the class. All right. So over here, if you FOIL this, right, expand, you will get x squared over 2, and then minus 2x divided by this, so it's minus x, and then plus 1/2, and then you have plus 2x, and then minus 2, and then plus 3 ln of x minus 1, and then you have plus c. So as you can see, I have x squared over 2, and then this and this like term, so that's plus x, and then plus 3 ln, whatever, x minus 1. And now, one thing that you're not quite used to yet because you're technically just starting out in calculus, these numbers get absorbed by c. They all get pushed into c, and you get plus c, and the solutions are the same. They didn't look the same, but as you expand everything and combine like terms, they are identical solutions. So back substitution can be used. Can be used. Yes, you can do either one. Yes. You will plug in x, you will plug in the lower upper right limit, you will compute it. So you get. No, you wouldn't. Because would you agree that this is a constant? And this is a constant, and you don't get to plug limits into those numbers, right? True. You write them first time for the upper limit when you plug in upper limits for all x's. And then you write them one more time when you subtract them for the second one, which changes their signs and they cancel. Right? Because you have to write it one more time for lower limits. And when you write it again for lower limits, because the entire thing is subtracted, their signs will change. So the second part for the lower limit computation, we have negative half and positive 2, and they cancel them out. So absorbing by C is proper. And the real time when you will be dealing a lot with this absorption by C is actually in differential equations. That's where you really get spanked with those. But now it's not that a big deal. We might see it a few more times along the line in Calc2, but much more in diffuse. This is a good one for next time you go out. To discuss over the dinner or something.
The first time someone goes, yeah, what do you know? Bring this one up. Like, you don't casual conversation. Like that one. Sure you did. And then when you're done, you establish that those parameters quickly. Yeah, I might teach differential equations next semester, by the way. Might. I can read it.
He has an iPhone.
He does? So he's not a real Android all day type of guy.
No, I'm just a hypocrite.
It's a phone.
I'm a hypocrite. I'm sorry?
You won't have Android-based music listening device. You don't listen to your music on your Android phone.
Oh, I do. It's right here. It's just that Apple is much better option when it comes to music.
When it comes to music. Much better option when it comes to a lot of things. Like getting simple things done.
I will do it.
Having an iPad means you don't want to know anything more about like computing and stuff. So then you don't want to know anything more about music.
By that logic, yeah. You don't want to know anything about music.
I was waiting for that drop mic.
Wait a minute. But I just saw you wore a shirt the other day that said, "Don't buy Apple products," as you have an iPod.
iPods are pretty cool, so.
Don't defend him.
Or do I?
I want to agree.
That's all points plus, man, because he's lost cause. Just keep smiling, good. Don't say anything bad. Exactly.
Like, where'd you get this 2 from?
So, you guys done with this one?
Yeah.
What is it? How we do it? U sub, exactly. What's U?
2 radical y plus 1.
And what's du?
1 over root y.
1 over root y. Yeah, wow.
Great. So this is actually a very simple problem, huh? It was in the book. Oh, okay. So the question is, very serious question, guys. Why is this over here u sub? Again, it's a function derivative pair, right? So we know that the derivative of root x is 1 over root x, and I do have 1 over root x, or root y in this case. So that was the reason. Function derivative pair. You always look for function derivative pair. And 1 over root y.
I wish I could just eyeball problems like that. Just be like, e to the u.
Eventually you will. Give a few years. No, I'm serious. Do you honestly think that I was eyeballing problems like that?
Yes.
Like this when I was taking it?
Yeah.
Oh, many people would disagree. Particularly the person who was teaching the class. I was sitting just like all of you. What the hell is this?
Someone's trying to learn fractions.
No, I go home and do puzzle, man. No, it was Counter-Strike. All right. From where to where? The peanut. We just got a dragon in a classroom. That's a dragon. I just can't see how many heads it has from here. Should have at least 3.
I'm like the smartest. I think the smartest like butterfly thing ever.
Yo, it's setting, yeah, that one is definitely 1%, man. That one is sitting in Calc2 class right now.
He's gonna go back to all his friends. He's gonna like learn how to build stuff. Calc2. Take over the world.
I was about to go there. It's gonna be Planet of the Butterflies.
Kill it.
Did you just say kill it?
Anything that becomes too smart. If they do anything else that becomes too smart, just kill it.
Yeah.
Yeah, that's why we have robots and kills. That's why we have Android phones that are explosive.
No, now there's washing machines.
Wow.
Alright.
Oh, that's a trick.
Is that a 0 for the lower limit?
Yes. It's not a cube root.
I did this one in my band.
It's a square root. They were asking because of the 3, was it a cube root? It's not a cube root. It's 3 times.
That's the trick. Power of
Yeah, so it's like 1 plus sine squared, take the cosine squared. Cosine.
There we go.
cosine of 3.
There's no divided by 2. And there's no cosine. There's no cosine.
No, but isn't there something like
There is
sine
something.
2x plus
There has to be
cosine?
Yeah, there's still like.
There isn't a density.
I think you have to.
Yeah, like.
I don't want to use a look though.
Or we can just make u unsine. Yeah.
So I picked this problem because I have no clue how to do it. Let's figure it out. Did I write this correctly?
Could have went with the easier problem, but I didn't.
I think he wants to do.
Of course. Remember where I come from.
Here are the 5 problems and 4 hours. Good luck. No better. Let's put that down.
We were all raised.
I know, which is why I'm not using 5 problems, 4 hours, and no better.
And then do the cosine.
Hour and a half. And no better. Actually, I should try it too. I can figure it out. No problem.
Hey, Professor. Professor, is there a way you can divide the square root so it's like the square root of 1 plus the square root of n? You said there's an area. What is it?
Sine 2x.
2 sine u cosine. It's cosine x cosine
Yeah.
x.
Yeah.
But I don't know.
I haven't gone further than that, but like.
Wait a minute.
2 sine x over
And then you use the.
Shows off.
You get the function that you're here.
Yeah, Roger the alien. I know I would give it up. I would just see this on the question answers. I would attach a smiley face for $20. $1 for each point for that one problem.
All right, we're making this the last problem from the review lab afterwards. I'm just gonna, yeah, we'll have to figure it out. So keep working on it for some time.
If you just pretend that that's 2 sine, that's 1 plus sine squared x, and and that would become cosine. You can imagination mode. Two sine 2x is equal to 2 sine x cosine x. So if we rewrite that in using use of as 1 plus sine of 2x, du becomes 2 cosine 2x through something.
Keep on staring at it.
I mean, if you look closely, it kind of looks like an Android.
Hmm? What? 3? I don't know, I haven't solved it yet.
So if it becomes 1 plus 2 sine x cosine x, theory. So you rewrote that as 2 sine x cosine x.
Oh my god.
Where did your 1 go? How was your 1? Yeah, that was your 1 from here to here.
That's what I'm saying. There's an equation that's one.
This one? Oh, that's
Instead of one, I do sine squared plus one squared to make the
Oh,
function.
yeah, gotcha.
Like that?
But then you're still missing your 2. Because your 2 sine x.
Yeah, sine x cos x.
Yeah, but this is cosine x sine x plus.
No. It's sine squared x plus
What'd you you had?
Huh? What's the answer?
Thank you.
Here. I don't know what you did, but whatever you did, I mean, I have the same answer, so.
I'm not gonna.
Huh?
That's a trig identity.
Yeah, maybe we should close those windows because more and more dragons are coming in. And eventually we're going to have the battle of these. You disturb the big dragon there.
So all that reduces to 1.
Yeah, you can go there. Is that dying? Here's the next one. Just you gotta use the chisel side, the thicker side. That way.
That's the Pythagorean issue. One equals sine squared x plus cosine squared.
So sine, I was on this something with sine squared x plus cosine squared x, which is 1 plus
And plus what we got from the other.
sine 2 sine.
We can see like that. Okay. It was like I think it was 3 done. Full credit.
So the stream is like, oh, it's just
Oh, the stream has no clue what's going on until he's done writing and explaining, and then I'm just gonna write it then.
She just like acted like we were moving on and then
But wait. So it's a squared plus 2ab or something.
Because when you're watching this at home, you can just skip through, right? So these long pauses, I just don't care.
So it's sine squared plus 2 sine. Wow.
Boss mode engaged.
So it was. I really wish I didn't do as much of the parting as I did in the first semester, because I would have remembered all of this. I suffer from short-term memory loss. First semester.
I'm gonna take a note to myself because I really want to.
Yeah, no one can.
He's got all the extraneous explanations on this thing. You know he's going to skip this.
You want to present it or you good? You want to present it or no? Yeah, you wrote the explanations, but you want to practice communication skills or no? It's not what I want, it's what you want. You think you're good? Yeah, well, everyone says you're good, so. All right. Yeah, that's correct. It took me some time to figure out that both identities need to be used. I tried forcing the double angle. I tried forcing the power reduction backwards and all these things. When nothing works, then you write one as the Pythagorean theorem, sine squared plus cosine squared, and from there is this one. All right, so we start by expanding this formula there, and then writing one as sine squared plus cosine squared, and if you rearrange terms, you will have sine squared x plus 2 sine x cosine x plus cosine squared x. You condense them using the square of binomial into a single term. That's where square kills the square root. You'll end up just with this. Integrating those is basic integrals, and then plug the limits, and it's 3. Bravo. Lab time. Get your groups. If you don't have a group, get a group.
Hey, Malcolm, you want guys want to come over here or you want us to come over here?
I don't know. That's whatever.
There's 3 of you and only 2 of us. Why don't we come here?
Alright.
Who are the other 2 people?
There's like no way that this can be right, but I got the same answer. I think.
I'll take a look. Let me just write for the stream and then the stream, and then I'll take a look at it.
All right.
Give me 1 second. So 1 is going to be sine squared x plus cosine squared x. And sine 2x is 2 sine x cosine x. Everything dx. We want to use a plus b squared is equal to a squared plus 2ab plus b squared. It looks like that, which means we rearrange the terms to look like that. Write the sine squared x first plus 2 sine x cosine x plus cosine squared x dx, which condenses into 0 to pi over 4 square root of sine x plus cosine x everything squared dx. Now these guys cancel, and we have the integral of sine x plus cosine x dx from 0 to pi over 4, which further integrates into negative cosine x plus sine x computed from 0 to pi over 4. Plug everything in and we get 3. Yay. Done. Bye, stream.